Time in minutes for engine's journey to work on Mondays has mean 38.4 and standard deviation 6.9. Find the probability that engine's mean journey time for a random sample of 30 Mondays is between 38 and 40. Mean journey time. So if X is the time in minutes for his journey on Mondays, then part A, we need to find the probability that X bar, which represents the mean journey time, is between 38 and 40. The sample size is 30. For part A, we need to find the probability that X bar falls in between 38 and 40. And we are given that the expected value of X is 38.4 and the variance of X or the standard deviation is 6.9. So the variance of X is 6.9 squared. We need to find the probability that X bar is between 38 and 40. So we need to know the distribution of X bar. We know that the expected value of X bar is the same as the expected value of X, which is 38.4, and the variance of X bar is the variance of X over N, which is 30 over here, N is 30. Then we have 6.9 squared over 30. Since N equals 30 is large, then from the central limit theorem, we know that X bar follows a normal distribution. The mean is 38.4 and the variance is the square of 6.9 over 30. Now to find the required probability, we find the probability that X bar is in between 38 and 40. X bar is a general normal distribution. We are given a standard normal table. We standardize this. We take 38 minus the mean, which is 38.4, and we divide by the standard deviation. So we have the square root of the variance. This is the variance, and the standard deviation is 6.9 over the square root of 30. So we divide by 6.9 over the square root of 30. This is less than Z. And we do the same for 40. So we have 40 minus 38.4 and divide by 6.9 over square root of 30. We know that Z follows a standard normal distribution. We now have the probability that Z is in between negative 0.3175 and 1.270. To find this probability that Z is in between 1.27 and negative 0.3175, we are actually looking for this area here. We have 1.270 and then negative 0.3175. We need to find this shaded region. We have a left tail probability table. So this region is actually the probability that Z is less than 1.270. We take this whole region here, and then we subtract that region. Okay, now, unfortunately, we cannot find this region in the standard normal table. So what we could do now is we work like this. Instead of using negative 0.3175, we have 0.3175, and we need to find this region. We can find this region from the standard normal table. That is 0.6247. So that this region is 1 minus 0.6247, which is 0.3753. And this part here from the standard normal table is 0.8980. Then we have 0.8980 minus this unwanted part, which is 0.3753. That gives us a value of 0.523. Engine wishes to test whether his mean journey time is different on Tuesdays. He chooses a random sample of 30 Tuesdays and finds that his mean journey time for these 30 Tuesdays is 40.2 minutes. So the mean now is 40.2 minutes on Tuesday. Assume that the standard deviation for his journey time on Tuesdays is 6.9 minutes. This is the same as the standard deviation for his journey time on Mondays as well. B, part 1, state with reason whether engine should use a one-tail or a two-tail task. So in this case, he certainly needs to use a one-tail task because we are looking at a different journey time. We are not testing whether his journey time has increased or decreased. It's just whether there is a difference. So we will certainly use a one-tail task. Part 2, carry out the test at the 10% significance level. So we are testing the mean journey time. We let mu to be the population mean journey time. The null hypothesis is that there is no difference from Monday. On Monday, we saw that, so for Mondays here, we saw that X bar follows a normal distribution with a mean of 38.4, and then we have a variance of 6.9 squared over 30. So we now assume that this becomes a population. We want to test whether there is a difference between the mean journey time on Tuesdays and on Mondays. Then we test the null hypothesis that mu is 38.4 against the alternative that mu is not 38.4. The test statistics that we use is a Z statistics. So we have X bar minus mu divided by the standard deviation sigma over square root. And here, we assume that this is a population. So the value of the test statistics that we have X bar over here is 40.2. That is the sample mean. We have 40.2, and we assume that these are all population now, so forget about the X bar here. Minus the mean, which is 38.4, and then you divide by 6.9 over square root of 30. That is 1.429. Then for the rejection region, or the rejection rule, you will reject the null hypothesis if the value of the test statistics, the absolute value because of the alternative here, is greater than Z of alpha over 2. Your significance level is 10%. Half of that is 5%, which is 0.05. And from the critical value, we have 1.645. You can get this from the standard normal table. So the rejection region that we have over here is, this is 0. We have 1.645 and the negative of 1.645. If the value of the test statistics falls into the tail area, the shaded region, then we reject the null hypothesis. But you see that 1.429 is somewhere here. It doesn't fall into the rejection region. So our decision here is to not reject the null hypothesis. We say that our decision is do not reject the null hypothesis. Now we can only say that whether we reject the null hypothesis or do not reject the null hypothesis in our decision. You cannot accept the null hypothesis. Then, conclusion. We can conclude that there is not enough evidence to conclude that. Now, in context of the question, what we do is we pick that from the question. So to conclude that, what we do is his mean journey time is different on Tuesdays. So that is what we pick from the question. You just copy that in your conclusion. To conclude that the mean journey time is different on Tuesdays at the 10% significance level. Part 3, explain whether it was necessary to use the central limit theorem in part B, part 2. In part B, part 2, when we are testing, we use the Z statistics. And this comes from the fact that we assume that the population follows the normal distribution. The original question did not state the distribution of the journey time. So for part 3 here, we need to use the central limit theorem because the distribution or the population distribution was not given. So over here, we say that the population distribution is unknown. And then also, n is 30, which is large. So we can use the central limit theorem. Otherwise, we do not know the distribution, then you cannot use the Z statistics.